Hi, I'm Kian, and today I want to show you how to solve this integral. Integral of tangent x over 1 plus cosine to the power of 4x dx. Now, first of all, because I want to make solving this question easier, I want to use the fact that cosine x, using the trig identity, the cosine x is equal to 1 over secant x, and secant squared x is tangent squared x plus 1, to a little simplify this. So I can write this integral as secant squared x times tangent x times tangent squared x plus 1 over tangent squared x plus 1 squared plus 1. And if we simplify this using the fact that tangent squared x plus 1 is secant x, secant squared x, we can simplify this and we will get tangent x over 1 plus cosine to the power of 4x. Now, the next step is to do a u substitution. So I'm going to let u to be equal to tangent x. Let u to be equal to tangent x. And by definition, du when differentiating, this is just du over dx. When differentiating it with respect to x, this is just secant squared x equal to secant squared x. And because our integral is in terms of x, we want to solve for dx. So dx is equal, let me write, dx is equal to 1 over secant squared x du. Now, the next step is to just plug in. But if you realize, when we use our value for dx, when multiplying, 1 over secant squared x and secant squared x cancel out to be 1. So we have a very nice cancellation. So I'm going to go to the next page. I have space here. I can write it here. So we have now the integral. Because secant squared x canceled, we have just u, which is tangent x, multiplied by u squared plus 1, which is tangent squared x plus 1. And then all over tangent squared plus 1 is just u squared plus 1, and then squared, and then plus 1. U squared plus 1, then squared, and then plus 1 du. So now I'm going to go to the next page and do another u substitution. So I'm going to use this color. I'm going to let u, in this case, to be equal to u squared plus 1 squared plus 1. I'm going to let u to be equal to the denominator. So u. I'm going to use another substitution because we have u. I'm going to use a v for this variable. It is better. I'm not going to use u because we have done one substitution in terms of u. Now I'm going to use another variable. So v, I let equal to be u squared in parentheses plus 1 and then squared and then plus 1. And then du, when differentiating dv when differentiating v with respect to u using the chain rule, we can just first use the power rule, 2 times u squared plus 1, because derivative of 1 is just 0. 2 times u squared plus 1, and then using the chain rule, we should differentiate the inside, so we get 4u times u squared plus 1. And then when solving for du, because our integral in terms of du, we get du is equal to 1 over, and then when dividing, we get 4u times u squared plus 1, and then multiplied by dv, because we're changing the variable. Now we are going to substitute in, and if you realize, if we plug in the value of du, you see that this u squared plus 1 with this u squared plus 1 cancels, and also this u with this u cancels. So we have the integral of 1/4 multiplied by 1 over v, because the denominator is also left. Because when we plug in du, when differentiating, we plug in u squared plus 1 cancels, and u cancels, so we are left of 1/4 times the integral of 1 over u. And because 1/4 and then du, because 1/4 is a constant, we can take it out of the integral. When I'm integrating 1 over u, this is just 1 over, 1 over, this should be v, 1 over v. Let me write it. 1 over v, because it's in terms of v. 1 over v dv. When taking out 1/4, integral of 1 over v is just a natural log of v. So we get natural log of v, and then over 4. And now you have to plug in our substitution. So this is just equal to, so we let v to be equal to u squared plus 1 squared plus 1. So we should plug in for v. So we get natural log of u squared plus 1 squared plus 1, and then over 4. But now we're not done, because we started our integral in terms of x. Now we should do another substitution. Our first substitution that we made in terms of x and u, we should plug in that. So if you come here, we let the u to be equal to tangent x. So now if we simplify this, if we put u to be equal to tangent x, for our final value, we change the color, we get natural log of tangent squared x plus 1, and then squared, and then plus 1, and then all over 4. And now we are done, but we can simplify this, because we know that when squaring this, we get tangent to the power of 4x and then plus 1. So we can also simplify this expression to be natural log of secant to the power of 4x secant to the power of 4 of x, and then plus 1, and then all over 4, and then a plus c at the end. Thanks for watching. Please subscribe to my channel and watch previous videos. Goodbye.